All right, greetings, math fans. All right, so this is day 9 of our calculus chapter, chapter 4a, and basically we're going to cover two different topics today. We're going to cover n-deriv, which is something on your graphing calculator, and we're also going to cover the second derivative test. Okay, so first let's talk about n-deriv. So it's n-deriv. Now this is going to be a nice little fancy feature on your calculator. If you have the newer version of the calculator, this is what I'm going to be showing you. If you have an older model, like you'll see you have an older TI-84 with the old operating system, first of all, you can update that operating system. So I'd recommend you actually do that so you have the nice full functionality that I'm going to show you. If you have an 83, you can't upgrade it, and so you basically, just to kind of give you a quick synopsis here, if you have a TI-83, you're going to use n-deriv, which is under Math 8. So you'll follow along here. You do everything the same. It won't be as nice as clean, but basically you're going to do n-deriv, and then it's going to be y1 comma x comma x. That's truly the only difference between what I'm going to show you and your TI-83. So the y1 is your equation you're going to use, and then these are just two parameters saying you want to graph the whole function, and x is your variable. Okay, so it's like with respect to x. Okay, so let's pull up a graphing calculator here that I have on my computer, and here's our nice little friendly graphing calculator. So this is the equation I'm going to put in your calculator. So actually, let me write it out here before I even get to that. The equation is going to be y is equal to 6x squared minus x to the fourth. So that's what we're going to find the derivative of that equation and show you how to find maxes and mins with the graphing calculator. Okay. All right. So let's put that in our calculator first. Of course, you can hit y equals. Now here's the deal. And I always sometimes people say, "Oh, Mr. Curtis, we got an error here. Something's going on." So I always tell the kids, cursor down to y, like you only see up to y7, go to y8, y9, and y0. Sometimes there's like random stuff in there, and that actually gives you an error. Okay, so just make sure that's all clear, and once that's all clear, then I'll just cursor back up to y1. Okay. All right. Make sure your plots are off as well. That's an important thing. So none of those should be highlighted. If they are, just hit the enter button and unhighlight them, and then we're good to go. All right, so let's type in our equation, 6x squared minus x to the fourth. Okay, and then hit enter. And y2 is going to be the derivative, so we're going to hit math. And you could just hit math 8 or you can cursor down, but math 8 is n-deriv. Let's just actually I'm just going to cursor down to it, because once I type it, there it is, n-deriv. Okay, so if you use that, again on the TI-83, it's just going to show up as n-deriv with parentheses, but with the 84, it's going to give you d by dx of the function, and then where do you want the function to go from what to what. Okay, so anyway, we're going to do d by dx, and now we could type in 6x squared minus x to the fourth, but why type in it again? So what you do is you hit vars, cursor over to y vars, hit enter for function, and there you go, y1 through y0, I guess. Okay, so we'll just put y1 because that's what we want to take the derivative of y1, and then you cursor over here and it says x equals, and then you're going to say x equals x. Okay, and now when you graph, well, we'll hit zoom 6, zoom standard, and this is going to, the TI-84 actually takes a long time. This actually is going a lot faster, but if you have the newer version, it goes faster. You have a little bit older TI-84, it takes forever. Like the color calculator just takes forever. Okay, so you notice I had two different graphs in there. And this is kind of messy. So just real quickly, one way to kind of shut things off a little bit to make it clear is if I cursor down to this guy and I go to the equal to sign, I hit enter, that shuts off that equation and it does the first one. So if I hit graph now, it's only going to graph the first equation, not the other one. Okay, so that's, you can see what the graph looks like. It looks like a nice, nice McDonald's M. And let's just, for the heck of it, let's shut off the second one. So let's, or the first one. So let's shut this off and then turn this guy back on. So, oh, sorry, I guess I didn't turn it off. Hit enter. Okay, so now it's just going to graph the derivative. So it might take a little bit longer because it has to first calculate the first function, kind of it's graphing it, and then it does the derivative after that. So this is what the derivative looks like. Okay, so that's kind of cool. It's a fourth degree polynomial for the original function, and this looks like a third degree polynomial, which kind of makes sense when you take the derivative, right, with the power rule, right? The exponent goes down by 1. All right, cool. So now think logically. If I gave you an f prime graph, in order to find the maxes and mins, right, if it's above the x-axis, you know it's a positive slope, and below the x-axis it's a negative slope. So take your hand and go like from this spot here where I'm pointing with the arrow, it's positive to negative. So positive to negative means it's a maximum. So I need to find this point here, this x value, and that's going to be where I have a maximum. All right. So what I'm going to do is I'm going to turn both graphs back on again because I think it's kind of important. So if I do that, hit enter. And again, on the color calculator, which I have, if I had one here, would be nice, but it doesn't have a color calculator with the this emulator here. But it helps you see the lines a little bit easier because the original function might be one color, like blue, and then the derivative function might be red. That's kind of handy. But let's just deal with it. Okay. So there's the original function, and then there's the derivative. Okay, cool. So you kind of have an idea what both of them look like. So what I'm going to do is I want to find the 0 for the derivative, because the 0 for the derivative is, as we all know, when f prime of x equals 0, that is a relative extrema. Okay, and so of course I already said that we're going from a positive slope above the x-axis to a negative slope below the x-axis of the f prime graph. That's going to give us a maximum. So what I want to do is find that 0. So I'm going to hit second, calculate 0, 2. And what happens is I want to do the left bound. Well, I've got two equations here. We'll see this y1. Right now I'm on the y1 equation. I don't want to find the left bound of the y1 equation. I want to find the left bound. I want to find that 0 of the derivative equation, which is y2. So this is a nice little handy thing. Just hit up arrow or down arrow. So if I hit up arrow, dude, it changes. See how it's now y2? That means my little, see a little cursor right at the origin right now? It is now on the correct graph where I can do a left bound, right bound. So you do up arrow and down arrow to move it between equations, and I move the left and the right to move around the one graph I'm on. So again, right now I'm on the derivative one. So watch, if I move the left, it's going to go to the left. See, I'm stuck on I'm on the derivative equation. So I got to go left bound. So I'm going to go left of that. So right, that's perfect. Left of what I want to find, the 0. Hit enter. Right bound. So cursor over a little bit more. There we go. That's good. Right bound. Hit enter. Guess. Hit enter again. And so there it is. X equals negative 1.73. So that's my x value where there is a maximum. It's pretty cool, right? How do I find the y value now? Well, I could find the y value by going and doing a table and plugging it in, or one of my students just a couple days ago showed me, he's like, his name is Andrew. Andrew's like, Mr. Kervis, he goes, why don't you just hit the up arrow button and it'll actually switch to the other equation. So I did. I hit the up arrow. And see how it says y1? I'm on the y1 equation, and look at that. There's the y value for that. So I'm still at negative 1.73, but now it gives me a y value of 9. I don't have to like type it in again. I can just switch back and forth. So again, if I cursor down, of course it's 0 because I found the 0 of the derivative, and I cursor up, and I'm now on the new equation. So Andrew was a brilliant kid and came up with that, and that's awesome. Showed it to a couple of my colleagues, and it works. Thank you, Andrew. All right. So anyway, that's that. If I asked you for a coordinate, now that would be what you would give me. You certainly wouldn't give me negative 1.73 comma 0. That doesn't make sense. That's the coordinate of the derivative graph, but I want to know where there's a relative max. Well, there's a relative max at negative 1.73 comma 9 on the original graph, on the F graph. Okay, and you know, let's do one more. It crosses, if you guys see right by the origin, it goes from a negative slope. So again, take your hand, negative slope to a positive slope, which makes this a relative minimum at about 0, 0, I think. Okay, so again, I'm going to do second, calculate 0, and we're going to go left bound. So I'm going to cursor over here a little bit. Oh, see, I'm on Y1. I don't want to be on Y1. So I'm going to change my arrow. I'm going to go on Y2. That's what I want to do. Okay, there we go. So now, see, the cursor's right down here, right below here. So I'm just going to get a little bit closer to, there we go. So that's the left side. Hit enter. And then I'm going to go to the right side. Okay, that's good. That's enough on the right side. Hit enter, and then it says guess. I'm not sure why it says guess, because you don't really guess in math, but it's okay. Hit enter, and there it is, 8.45 e negative 18. Well, what does that mean? Of course it means 0, right? It's a rounding error. You know, it's 8.45 times 10 to the negative 18th power, which is basically 0. Okay, so what's that in the y, or the other equation? So I'm going to hit up arrow to go to the other equation. And again, you know it's the other equation. Look up here. It says y1 equals 6x squared minus x to the fourth. That's the original equation. I'm on the original equation, and here it is, 8.45 e negative 18. And here's the y value, 4.2 e negative 34. So that truly is at 0, 0, I truly have a relative minimum. Okay? And then, of course, I can do it for one more. I'm not going to do that, but I can do that for the other maximum at this location here on the right. You know, like I said, to find that relative max. Okay, so again, it's pretty easy. Hopefully, this is good. You know, using the up arrow and down arrow to shift between equations. Use the right arrow and left arrow to actually move around that equation, and using end deriv, and it's just a super handy equation. But here's the deal: you're going to see a problem like this where I might just say, given this f of x, find the maxes and mins. And a bad thing to do is literally to go second, without doing the derivatives, do second calculate and do minimum and maximum. Now obviously if it's a multiple choice question, you can do that. You think they're going to give you multiple choice questions like that in the AP exam? Probably not. Okay, you're going to have to use some calculus to do this. So this is the way you do it. You actually do the derivative, and then you find the zeros, and then you use your own logic to say, you know, what's going on. Now I want to point out that you're still going to use the same words, okay? So let me go back to the Word document now. We know that one of our, relative extremes, we had a relative max at negative 1.73. So I kind of want you guys to understand that I'm still going to say, you know, our official words, right? I'm going to say there is a relative max at, and if I ask you for coordinate, which we did, it was going to be negative 1.73 comma 9. That was our number. And you can say since f prime of x is equal to 0, or really could say, instead of f prime of x, you say f of negative 1.73. I don't care how you say it. If you say f prime of x equals 0 at negative 1.73, or at x equals negative 1.73, or f prime of negative 1.73 is equal to 0. I personally like it this way, because then you say and f prime of x is changing. And don't use the word going. That doesn't sound very mathematical. And f prime of x is changing from positive to negative at x equals negative 1.73. Okay, so you're still using all the words that we learned, but now you're using your graphing calculator to look at the derivative graph and come up with this conclusion. Okay, all right. So just again, a quick review. Make sure you guys know about value. I think I'll even mention that a little bit later. But right, if I ask you for a value, the value is 9. If I ask you for a coordinate, it's this. If I ask you for an x value, it's negative 1.73. So just be careful what I'm asking for, because AP graders are going to ask you for specific things. So give them what they want. Okay. All right. So that is that's a graphing calculator. Okay, all based on just that derivative graph. All right, sweet. So let me clear this out here, and let's do the second derivative test. Okay, second derivative test. All right, so second derivative test, basically, math fans, if I have a critical point, let's say the critical point is here. Okay, which pretty much means f prime of x equals 0. So that just gives us a critical point. It doesn't guarantee we have a relative extrema. It doesn't, right? Because if we do our interval testing and it's minus minus or plus plus, it's not a relative max or min. So what the second derivative test does, instead of actually doing an interval testing with the first derivative, the second derivative test is this. So think about it. If this was a minimum point, do you guys agree with this? What can you tell me about that line in terms of f double prime? Okay, wouldn't you tell me f double prime of x? It's what? Well, what is this? It's concave up, isn't it? This one's concave up. So if it's concave up, f double prime of x is greater than 0. So think about it. If you're testing the point and the second derivative is greater than 0 at that point, and so that means it's concave up, that means it's a minimum point. It's almost a little counterintuitive because you think concave up, oh, it's maximum. But look at the graph. This is concave up, which makes that a minimum point. Okay? Same. So this is really case 1. And then, of course, case 2 is kind of the same idea. Let me draw that same point here. And again, it's a critical point, so I know f prime of x equals 0. But again, not necessarily relative extrema. So you're going to do f double prime of x, and if it's less than 0, that means it is concave down. This was concave down, looks like, right? Like that. Concave down. Right, so concave down. So, right, if it's concave down, what does that mean? That's a maximum. Again, a little counterintuitive because you think, oh, greater than is max, but just draw it and think about it. Oh, if it's concave up, that means that's you got the low point there, and that would be a minimum point, and it's concave down, that's a high point, and you would have a maximum point. Okay, relative min and relative max. All right, so how do you know when to use this? You might just be given information about concavity. And if you're just given information about concavity, then you know what's going on, like in a chart, for example. Okay, if you're given a chart that says has plus, so it says f prime of x equals 0 and f double prime of x is greater than 0. You know, if again that would be concave up, you know this point then would be a minimum point. Okay, and vice versa, if f double prime of x is less than 0, it's a maximum point. Okay, so I would, on a quiz or test, I would specifically say, hey, using the second derivative test. So I can kind of put that on here. Specifically asks for second derivative test. Okay, beautiful. All right, so and these are the words you're going to use, and we'll do an example here in a second. But the words you would say, for example, if this was at 3, 1, 2, and 3. So here are your words. The words would be f of 3 is a relative max since f prime of 3 equals 0 and f double prime of x is less than 0 at x equals 3. Okay, so you told me it was a critical point, and then you told me it was concave down. So again, concave down means it's a maximum, relative max. Okay, so these are the words. So know this. Okay, you should know this when you're describing it with the second derivative test. All right. All right. So let's do one example here, math fans, and to show you what I'm looking for. Okay. So here's the problem. Y is equal to x cubed minus 6x squared plus 9x. All right, so first thing I'm going to do, y prime, 3x squared minus 12x plus 9. So I'm going to find my critical points first. And of course, I'm going to set that equal to 0. So we factor 3 out of there. You get x squared minus 4x plus 3. Set equal to 0. So if I factor that, I get x minus 3x minus 1. So my critical points are 3 and 1. All right. So again, there's no interval testing here. If you do interval testing, you really didn't do second derivative test. So the next thing I want to do is I want to find y double prime. So let's do that up here. Y double prime is very simple. It's just 6x minus 12. Okay, 6x minus 12. Pretty easy. So based on what I'm doing here, math fans, I am just testing these points out. I want to see what at x equals 3, is it concave up or concave down? So that's all I'm doing. It's really easy. So y double prime of 3 equals 6 times 3 minus 12, which is 18 minus 12, or 6. So I don't even care the number. I just care that it's positive. So this means it's concave up at x equals 3. So what does that mean? Think of it. Just use your hand and look at it. Oh, that means it's a minimum point. So minimum point. Okay? And then y double prime of 1 is 6 times 1 minus 12. So that gives us 6 minus 12 is negative 6. So that is negative. So that's going to be concave down at x equals 1. All right. So basically what you're going to do here is when you now write the words, you're going to say, again, 3 comma, well, you plug it back into the original problem, right? In the original, if I plug a 3 back into here, I kind of did the math already, but it's 3 comma 0. So 3 comma 0 is a relative minimum, or is a relative, yes, minimum. I just had to go back and look at this. It's a relative minimum because it was concave up. Since, sorry, let's cursor down here again, sorry. Since y prime of 3 equals 0 and y double prime of 3 is greater than 0. That's all you need to know. That's beautiful, right? Critical point, and it's concave up, so it's a minimum. Beautiful. That's the second derivative test. And the other one would be 1 comma 4 is a relative maximum since y prime of 1 equals 0. And again, I got that 4 from plugging in the original equation. So y prime of 1 equals 0 and y double prime of 1 is less than 0. Okay, so those are the words. If I don't see these words, man, you will not get full credit for your problem. All right, so remember, one more time, you guys are tired of hearing this. Okay, if I ask you for a coordinate, you're going to give me the whole thing. Okay, if I ask you for an x value, you're going to give me the x value. Okay, if I ask you for just a value, you're going to give me a y value. Okay, or if I say the y value, but a value is the y value. I want to know how high and low it's going to go. I don't care where the x value is unless I specifically say the x value. So make sure you are careful with what I ask for. All right, so that's it, math fans. A little graphic calculator, a little second derivative test, and that's it. You have an outstanding day, math fans. Adios. Goodbye.